Today, we will be learning how to solve probability problems using probability trees. Let's take a look at our first example problem. Sophia drives herself 45 minutes every day to get to school. Her car is really old and unpredictable. The probability that her car breaks down on her way to school is 4/9. If her car breaks down on the way to school, the probability that she is late to class is 3/4. Even when her car doesn't break down, the probability that she is late for class is 3/8. The first step to learning how to solve probability tree problems is understanding how to fill one in. Let's try it. The first two branches are representative of the independent variable in the problem. For our problem, this is whether or not Sophia's car breaks down. We're going to use the letter C to represent this variable. The apostrophe added to the C means not. So C apostrophe is the probability that Sophia's car does not break down. The next step is to make the next level of branches. Each original branch splits off into two of its own. These branches represent the dependent variable, which in our case is whether or not Sophia is late to class. It's dependent because the likeliness of it happening depends on whether or not her car breaks down. Let L be the probability that Sophia is late to class. Now, the problem does not explicitly tell us what the probability that Sophia's car does not break down is, but because we know the probability that it does break down, we can figure it out. Her car is either going to break down or it isn't, so the probability that it does and the probability that it doesn't need to equal 1. So since we know that the probability her car does break down is 4/9, we know that the probability that it doesn't must be 5/9. Next, we know that if her car does break down, the probability that she will be late to class is 3/4. Knowing that the probability something does or does not happen needs to equal 1, we can conclude that the probability Sophia is not late to class if her car does break down is 1/4. The same thing goes for the probability that she is not late for class if her car does not break down. It's 5/8, since the probability that she is late for class is 3/8. We've now completely filled out the probability tree for this problem. The next step is learning how to utilize this information to answer questions. Let's take this problem to the next level. Question 1. What is the probability that Sophia's car breaks down, but she is not late for class? There are some basic things to remember about probability before we start solving the example problems. In probability, the word and means multiplication, and the word or means addition. So when a problem asks you for the probability that blank and blank happen, you multiply them together to get the answer. But when a question asks you for the probability that blank or blank happens, you add the two together. So let's think about this. If we want to find the probability that Sophia's car does break down and she is not late for class, we should, that's right, multiply. Okay, so we take the probability that her car does break down, 4/9, and we multiply it by 1/4, the probability that she is not late for class, to get 1/9. Question 2. What is the probability that Sophia is late for class? This question is a little tricky. You have to remember that there are two ways Sophia could be late to class. 1, if her car does break down, and 2, if her car does not. So first you need to find the probability that her car does break down and she is late for class. You would multiply 4/9, the probability that her car breaks down, by 3/4, the probability she is late for class if her car does break down. This is 1/3. Next, you would figure out the probability that her car does not break down, but she is still late to class. You would multiply 5/9 by 3/8 to get 5/24. The last step is to add the two probabilities together. 1/3 plus 5/24 is 13/24. This is the total probability that Sophia is late to class. Let's move on to problem number 2. James loves to play soccer on the weekends with his friends when he doesn't have homework to do. The probability that James gets assigned homework for the weekend is 3/4. The probability that he still has time to go outside and play soccer is 2/7. When he doesn't have homework, the probability that he can go outside to play soccer is only 1/2, because sometimes his mom wants him to stay inside and finish his chores. Let H be the probability he does get homework, and S be the probability he gets to play soccer. Pause the video now and try to fill out the tree on your own. When you're done, come back and check your answers with mine. The first thing to do is fill in your tree. Remember, the probability an event does and the probability an event does not happen must equal 1. The probability that James does get assigned homework is 3/4. So the probability that he doesn't get assigned homework must be 1/4. If he does get assigned homework, the probability he can play soccer is 2/7. So the probability that he can't is 5/7. If he doesn't get assigned homework, the probability he can play soccer is 1/2. So the probability he can't play soccer is 1/2 as well. Now let's put this to use. Try to solve the next 3 equations on your own. Question 1. What is the probability that James gets assigned homework and can play soccer? Question 2. What is the probability that James doesn't get assigned homework and can play soccer? Question 3. What is the probability that James can't go outside to play soccer? Pause the video now. These are the answers. Keep watching and I will explain how to get there. To find the probability that James gets homework and can still play soccer, you would multiply 3/4 by 2/7 to get 3/14. To find the probability James doesn't get assigned homework and can play soccer, you would multiply 1/4 by 1/2 to get 1/8. To find the total probability that James can't play soccer, you would multiply 3/4 by 5/7 to get 15/28, and multiply 1/4 by 1/2 to get 1/8. Then add 15/28 and 1/8 to get 37/56. Here are all the answers again. How did you do? I hope this helped. Thanks for watching.